Thank you, Bob. And good afternoon. What I thought I'd do today is talk about software-defined networks. There's been a lot of industry interest in software-defined networks. And what I'd like to do is start with the observation that, in October 2009, when we launched the new network, we actually talked about 3 goals that the new network had. Number 1 was to increase the rate of innovation. Number 2 was decrease OpEx for our customers through automation. And number 3 was to decrease CapEx for our customers through the best use of technology. If you now roll forward to 2012, by the way, in 2009, the term SDN did not exist. You roll forward to 2012, and you ask the question about what are the goals of SDN. It turns out that the goals are exactly the same, completely identical. So the strategy that we've been on with the new network was, in fact, an SDN strategy if you just apply the current fashionable term. Now, what I'd like to do in this ChalkTalk is answer 4 key questions. First one is, what is SDN? What is software-defined networks, and what is it not? There's a lot of confusion about that, and everybody has their own view about what SDN is. It's something like cloud, right? Whenever a term becomes fashionable, lots of people have different interpretations. I'd like to give you our interpretation of what SDN is and what it's not. Second is, it turns out that the concept of software-defined networks is relevant in some domains and not so relevant in other domains. And I want to take you through why that is the case, so you get some idea about what we might focus on. And as Bob mentioned, we believe that the data center domain is the most important one for SDN. A third question, which many of you have in your minds, I'm sure, is SDN a threat or an opportunity for Juniper? Well, let me say it right up front. We see SDN as a very, very strong opportunity. It's not a threat. And then I'd like to take you through, like we do for everything else, we use a principles-based approach to solving problems. And so I'd like to take you through the 4 principles that we have behind our approach to SDN, and then take you through some details of what we're actually doing. All right, so the first question is, what is SDN? So what I'm going to do is draw you the simplest possible picture of a software-defined network up here. And that simplest possible picture consists of a piece of software, generally called a controller. And this controller runs on horizontally scalable x86, Intel x86 servers. There's also a network which is built with a bunch of networking nodes, somehow connected to each other, etc. So this is the network. And the controller is, of course, connected to the network nodes using some kind of a control plane, some control connections. And this interface, very importantly, between the controller and the network being controlled, is intended to be an open standard interface. This piece is very, very important. And as I'll mention later, OpenFlow is one possible proposal for this being the open standard interface. Now, when you look at this picture, you see these 3 elements: the controller, the interface, and the network. Well, first observation I'd make is that this network there has to be a physical network that's being controlled. The network is built out of some form of nodes. All of the forwarding path of these network nodes is implemented inside these nodes. It's not implemented by the controller. So in general, if you look at the functionality in the network, you can break it down into 3 pieces. Data path functions, which is moving packets. Control functions, which is actually computing the tables that on the basis of which the forwarding is done. And the third part is the management of the network. In general, data path functions remain in the network. Management functions are always centralized, and control functions can either go here or stay in the network. Now, why did SDN happen? Well, it turns out that SDN is a recognition by the networking industry that not all problems can be solved by putting the functionality inside these network nodes, which are generally geographically distributed. You know, the very essence of a network is that these network elements are spread out over space. Maybe it's over a wide area, maybe it's inside a data center, but they're not all put in a small space. So there's actually two trends. One is that not all functionality can be implemented in a distributed way. In fact, if you try to centralize the functionality, it can be implemented a lot better. And I'll give you 2 examples of that. One is if you want some statistics on a network, on how well it's working and so on, that functionality is actually much, much better implemented in a centralized way. Another thing that is much better implemented in a centralized way is if I want to do network provisioning. Well, if I try to do that computation in a distributed manner, it turns out to be NP-complete. A very, very hard problem to solve. In fact, there's no optimal solution, or the optimal solution takes too much time. So on the other hand, if I put it in the center, it's actually fairly straightforward to do it. So that's one trend. The second trend is that the IT industry, the broad industry, has actually figured out ways to use massive amounts of horizontally scalable general purpose compute power. And the kinds of things that this controller does can actually exploit that technology, which is now becoming generally available. So those are the 2 trends. Now, I'd ask you to notice that, you know, we had expressed an important principle back in 2009 with the new network, and that principle was centralize what you can, distribute only what you must. And the reason we articulated that principle was because it's an important organizational principle for simplifying networks and, in fact, information technology in general. And so SDN, or the fundamental architecture of software-defined networks, you can see, is trying to centralize those pieces or those pieces of function that can be better performed in a centralized way, but leave the functions that are performed better in a distributed way down in the network. So that, in a nutshell, is SDN. Now, what I drew for you is a very, very simple picture. And like any simple picture, it's not a real picture. That is, in any real installation, what you will find is that in almost every case, I'm going to end up having multiple controllers. Why? Because a single controller can't scale. Also, so these controllers are going to have to talk to each other. They'll have east-west interfaces. It's also the case that in any given installation, I don't just have the network. I have network and storage and computing. So I need a higher level orchestration system, so I'll need some northbound interfaces also. So the picture that I drew was very simple, but in essence, it's correct if you abstract it out completely. Now, the other very important point to note about this is that if I am running on every one of these nodes a different operating system, it actually makes it quite hard to write a controller that controls all these things. So we believe that the fact that all of our equipment runs Junos actually makes it much, much easier for us to do it compared to our competition. All right. So now let me talk about the trade-offs between centralization and distribution. It turns out that you can see that almost all the discussion around SDN is going to be, it's going to revolve around the topic of what functionality should I centralize and what functionality should I distribute. And so the thing that may not surprise you is that we've actually been here before. And so you'll all wonder, well, how come we've been here before? SDN is a new concept. It just, people announced it this year. Well, it turns out that we have been here before. So if you look at distribution versus centralization for the network, go back to the telephony network. This was a TDM network. And if you ask the question of how much of the functionality was centralized and how much was distributed, well, it was something like this, that this is functionality here, and this is the stuff that is centralized, and this is the stuff that's distributed. And the portion of the functionality that is distributed in the switching nodes was very, very low. So that's what the picture looked like a long time ago. Why on earth did we go away from that? Well, we went away from that because this stuff did not scale for packet switching. It did not scale when the end users were not people making phone calls, but computers whose performance was doubling every 18 months. Okay? So we then went to a packet switching world in which we are still today. And here, the bulk of the functionality was implemented in a distributed way. And yes, you had network management systems, which were relatively centralized, but their role was primarily to configure these devices and then let them do their thing. So most of the action was happening down here. Now, the SDN purist view is that I'm going to put the bulk of the functionality up here, and I'm going to remove all intelligence and functionality out of the network. There's some challenges with this view. What are the challenges? Well, first thing, if you have a network that you put together where a whole bunch of nodes are connected to each other, before the controller can talk to these nodes, you have to have a network that's up and running. So you might sense this notion of chicken and egg. If I don't have a network that's up and running, the controller can't talk to it, so how can this thing work at all? Well, it turns out that there is a minimum amount of functionality that must be implemented in the network, and that minimum amount of functionality is not so small, as people might like to think. So that's one challenge. The second challenge is that SDN, or software-defined networking, is indeed in its honeymoon phase. And in the honeymoon phase, anything is possible. The world is rosy. I can do lots and lots of things. I can write one controller that can control 1 million devices, et cetera. Well, as we get experience with these things, we will find out that the world is not as rosy as it looked. I'm probably going to have half a dozen controllers. I'm going to have to acknowledge that there's distribution. I'm going to have to put back functionality here. So let me draw you Juniper's view of how the functionality might be split, the most likely scenario. The most likely scenario is that you're going to have functionality in the controller, and you're going to have some modest amount of functionality in the network. Now, I would also say in the same breath that this distribution of functionality will be different for different domains. Why do I think so? Well, think about it this way. If my network itself, like in the data center or in campus and branch, is already relatively centralized compared to the internet, I may be able to simplify the functions in my network nodes and put more functionality here. But if I go out to, say, the core of a service provider network or the edge of the service provider network or the access aggregation network, pulling this trick is actually much harder. And in fact, I won't be able to get it to scale. In essence, I'll discover the same problem that carriers discovered way back when, which led to the invention of routing. Okay? This is basically routing. So that's kind of gives you a perspective that, you know, guys, we've been here before. The pendulum may have swung a little bit too far. And I think the availability of lots of cheap, very high performance computing gives us an opportunity to perform some of the functions in a more centralized way. And we completely agree with that. We think that that's a great idea. And we are, in fact, making investments to make sure that we can exploit the fact that we have a single operating system to its best possible use. OK, so we talked about what is SDN. So let me now mention what it's not. SDN is not the same thing as OpenFlow. There's a lot of confusion about this. OpenFlow is one proposal, an early proposal for the open protocol between the controller and the network. That doesn't make it SDN. So it's not right to confuse the two terms. It is also not a replacement for the peer-to-peer network. Because as we mentioned, you know, the data path certainly has to be implemented by the network. The control functions, when the network is geographically distributed, has also to be implemented in the network. So it's not right to say that, hey, the entire networking functionality can be implemented in the SDN controller. Well, the third thing that SDN is not is it's not yet another encapsulation protocol. Like VX, you know, there have been at least half a dozen overlay networking encapsulations that have been proposed. VXLAN, Trill, NVGRE, OTT, you name it. And I'm almost sure that you wait another 4 months, there'll be another one. Well, none of these encapsulations actually solve real problems. What they do is they make work for programmers in lots and lots of companies. So our approach to the problem is a little bit different. It's not to reinvent the wheel each time, but to solve the problem once and solve it well. All right, so I mentioned that there are some domains in which SDN is more important, and in some domains where it's less important or less relevant. And certainly the distribution of functionality between centralization and distribution is going to be different across the domain. So let me now give you sort of the, at this end it's highly relevant, and at this end it's not so relevant. Well, we've already said that the most relevant domain is data center. The next most relevant is campus and branch. Probably the one that comes after that is access aggregation. Probably the one after that would be WAN, core, edge. And it's not a strict ordering. But generally, the more geographically distributed your network, the less it becomes possible to put more and more functionality in a single controller in the sky. So it's essentially that simple. So our focus is going to be on the data center. So now let me talk for a few minutes that I have remaining about our approach to SDN. Well, first thing about our approach is that it's going to be a balanced approach. A balanced approach means that we're going to put the right functionality in the right place. Right place meaning in the controller versus in the network. What we're going to do is not put too much functionality into any one piece, because that leads to complexity, that leads to unreliability, and so on. Our approach is also principled. We follow 4 principles. And those 4 principles are centralize what you can, distribute what you must. I already talked about this one. The second principle, which Kevin mentioned also, is design networks using the smallest number of general building blocks. The third one is automate anything that can be automated. This is nothing more than the history of technology. In fact, this is a definition of technology. Technology is something that automates tasks that were previously manual. And then the last one, which is very, very important, and which is a great differentiator of Juniper, in other words, it differentiates Juniper from any of its competitors, is that we support open standards wherever possible. In fact, I can't recall a single product where we expose non-standard interfaces outside unless there's a very, very, very good reason for doing that, right? And where there doesn't exist a standard, we will propose a standard and then publish it. So we also, the last part about our approach is that the approach is focused. We don't believe, first of all, that SDN is equally applicable everywhere. So we're going to focus it on the data center. And we're going to start there. And then once we see how that goes, we may apply the approach to other domains where it's relevant. So now let me close with these 4 thoughts. The first, just to summarize Juniper's view. First is that the goals of SDN and the new network are exactly the same. The second is that SDN does not obviate the need for doing innovation in systems, because there is significant functionality in the networking elements, and this will remain true because of the balance. The third one is that Juniper always has and always will support open standards. The incumbent has already placed or made statements about what it intends to do with SDN, and the fact that it has the intention to control the standard. Well, Juniper has no intent to control the standard. What we want to do is we want to see open standards develop. We don't want to do standards plus. We want to have open standards, and we want to exploit the fact that we have a single operating system, which will make it a lot easier for us to do things. And then the last point, which is that SDN represents for us a strategic opportunity to lead in the networking industry. And we put this marker down 2.5 years ago in October of 2009 with the new network. Thank you very much.